Welcome to the tutorial on seismic analysis of multi-story building using equivalent static method and response spectrum method. The buildings which are designed by IS 456 considering only the gravity load, that building would collapse during earthquake. But when you consider the seismic loads as per IS 1893 and given proper ductile detailing to the building, that building could withstand the earthquake force. So in this video, we are going to model and analyze the equivalent static method and response spectrum method. The seismic analysis can be broadly classified into two spectrums. One is static analysis and dynamic analysis. Both static and dynamic, we have two methods. One is linear and the other is non-linear. So the equivalent static method is a linear static analysis and the pushover is a non-linear static analysis method. The response spectrum method is a linear dynamic analysis and the time history analysis is a non-linear dynamic analysis. In this tutorial, we are going to consider the equivalent static method and the response spectrum method. Now, when to consider this method for analyzing a building? For that, IS 1893 provides certain conditions to be satisfied. So when these conditions are satisfied, then you can consider either of this method for your analysis. So the equivalent static method is applicable only for simple and regular structure, and they consider it has single degree of freedom behavior, and they assume that the building responds to its fundamental mode. And the third point is the building can be from low rise to medium rise. It cannot be a high rise. The word they have provided that the building can be from low rise to the medium rise, must not twist significantly when the ground moves. So the torsional effect is not considered here. And as per IS 1893 part 1, page number 14, the equivalent static method can be used for analysis for regular structures with approximate time period less than 0.4 seconds. So the building with frequency more than the time period more than 0.4 second, then you have to consider response spectrum method. And the building height which is less than 15 meter in seismic zone 2, then you have to consider the equivalent static method. Now when these conditions are satisfied, then you can consider the equivalent static method for your analysis. Now the next part, the response spectrum method is applicable to unusual building configuration and they consider as a multi-degree of freedom. Now in response spectrum method, the mode shapes and nodal mass participation of the structure for different building frequencies is provided, and the response spectrum will be performed by using the design acceleration spectrum or the site specific design acceleration spectrum. So we have the response spectrum curves available in IS 1893 2016, two curves, and other than the regular buildings, other than the normal buildings, height less than 15 meter in seismic zone 2 is considered in response spectrum. So it means that the fourth point says that if the building is unusual in configuration and it lies in zone 2 and the height of the building is also less than 15 meter, then you have to consider response spectrum method for analysis. And the other point is that the building height which is more than 15 meter in all of the seismic zones, then also you have to consider the response spectrum method. These are the steps involved in modeling the structure in ETAP. First, we have to give the basic details of the plan and the building height and the grid lines in the first pop-up. Then we have to define the material, the grade of concrete and the grade of steel which is being used, that is the rebar. We have to define the frame sections, that is the dimensions of the beam, column and the slab. And we have to define the function, the response spectrum as per IS 1893 2016 codebook. We even have 2002 codebook also available in ETAB. And we have to modify the function type. In the modification of the function type, we will be provided with the zone factors, the soil type. Depending upon your project, depending upon the details which you have available, you have to modify the function type. And we have to define the load pattern. By default, ETAB defines the dead load and the live load. We have to define the wall load, floor finish and the earthquake load in X direction and in Y direction, and the response spectrum method in X and Y direction. Then we have to draw and assign the structural members to the grid system, and we have to apply the wall load on the beams and the live load on the slabs. Then we have to apply the dead load or the floor finish load on the slabs. Then selecting the column and beams, we have to assign the end length offset. Then we have to assign the diaphragm. Now we have to modify the load cases. For example, the response spectrum, we have to choose, is it linear or non-linear, or the acceleration in which direction. Those things we have to modify in the load case. And we have to assign the support condition, whether it is fixed or hinged or pinned. We have to modify the mass source. Then we can analyze the model. After analyzing the model, we can check the results. We have to see for the nodal analysis, the time period, base shear, and as per IS 1893 codebook, if the design base shear of the response spectrum is less than the equivalent static method, then we have to modify the response spectrum scale factor by dividing with the equivalent static method, and the corresponding scale factor should be applied in response spectrum load case. And other parameters are also available in the results. We have to check the maximum displacement, maximum story drift, absolute acceleration, and so on and so forth. New model. We will use built-in settings. So by default, we are going to choose the steel codebook as IS 800 and the concrete design codebook as IS 456. Now the grid lines in X and Y direction is 4, 4, and the spacing of the grids is going to be 5 meter. This is going to be a symmetrical building, and the number of stories is 4 and the typical story height is 3 meter. To draw much easier and in a faster way, we are going to select two-way ribbed slab option. So in this option, we are going to uncheck the ribs. So basically we are going to have only the ordinary RCC slab. In this option, by default we have the concrete column and concrete beam predefined. So we are going to only change the dimensions and assign the members. So here we have unchecked all the specification mentioned here, and the rib is also unchecked here. The support condition is fixed. The diaphragm is going to be rigid. The dead and live load, we will assign it in the modeling process. The slab is one, and the beam in X direction, that is the main beam, and Y direction is the secondary beam. So right now we are going to consider all the beams as same. Concrete beam, same for X and Y. Now we will click OK. Again OK. Okay. Now the model is extruded here. So for better visibility, I'm going to close this model explorer here. I'm going to drag this here. Now it's quite big. Now the first step, we are going to define the material property. Here we are going to add new material. We will select the region as India, and the material type is concrete M30 grade. Okay. Again okay. Add new material. Now we are going to choose the rebar. The longitudinal bar is 415. Again okay. Okay. New material. The rebar, the mild grade is 250. So we are considering this grade for the confinement bars. Again okay. So we have defined the basic material. Concrete and the rebar has been defined. The next step, we have to define the section properties. In that we have to define the beam and column dimensions. So here, go for the frame sections. Concrete beam is available. Now we are going to modify concrete beam. The grade is M30. The depth is 300 mm and the width is 230 mm. We are going to modify the rebar here. Just check M3 design only. So this is for beam, and these both conditions would be useful for the pushover analysis. But right now we are considering the equivalent static and response spectrum only. The longitudinal bars is going to be FE415, and the confinement bar, which is the ties, the stirrups. So this is going to be mild steel 250. So these are the default values. We'll click OK. Again we'll click OK. Now we'll go for the concrete column. We'll modify the number. Again we'll choose the material as M30 grade. The depth is 350 and the width is also 350. Modify the rebar. Again for column PM2 M3, the longitudinal bar is 415 and the confinement bar is 250. Basically we are going to only do the analysis part. I'm going to just give the rebar values as 16, 16 and 8. So that the reinforced system be designed. Now click OK. Again OK. Now the frame sections have been defined and the dimensions have also been changed. Now again OK. Now we have to define the slab member. The same step, go for define, go to the section property, slab sections. Here we already have slab 1. We will modify the slab dimension. The slab material is M30 grade, thin shell. This is 150 mm. Okay. Okay. So now we have defined the material and the frame sections, beam, column and slab. The third step is that we have to define the function. Again we'll go for define. Here is the function. And here we have the response spectrum. Here we will choose the Indian code book. See, we have IS 1893 2016 and 2002. We are going for the new edition 2016. Add new function. Here for our easy understanding, we are going to change the function name as a response spectrum. It is zone 5 and the substituted value is adopted here. So if you change for zone 4, this value will change and the period and acceleration will also change. This is based on the response spectrum curve which is available in our code book. So right now we are considering for zone 5. The importance factor is 1.2. Response reduction is going to be 3 only. It's a ordinary frame. Click OK. Okay. Again, we will. The next step is we have to define the load pattern. So we'll go down here. Here is the load pattern. By default, we have the dead end live load. Now we have to define the wall load. So for shortcut, for representation, I'm going to just use WL as wall load. Wall load is super dead. Add new load. And we'll have the floor finish also. Again, that is also a super dead load. Add new load. After that, we'll have the earthquake force in X direction. That is going to be seismic type. Seismic, not the drift, seismic. Here, just click here. We will have the drag down menu. So here, we will consider the IS 1893 2016. Add new load. Now after getting here, we will modify the lateral load. So this is in the X direction. So we will consider only the X and uncheck the other directions, Y direction and their eccentricity. So X direction plus eccentricity plus or minus also been unchecked here. So we will consider only the X direction. Then the response reduction is 3. Again, it's in zone 4, it's all mentioned here. So here we have the time period been calculated by the ETAP software, or else you can even give the time period value as per the codebook formula. The TA is 0.09 h by root d. So the h is the height and the d is the span length. So by calculating, you can give the value also. Right now we are considering the program calculator. Let the program calculate it. You have this option to consider the time period also. You can also give your own time period. So we are going to consider right now only the program time period calculated. Okay. So earthquake in X direction, we have given the load pattern. Now we'll go for the Y direction. Same conditions, just click add new load. Now it is added down, we have to modify the lateral load. Now here it is only for the Y direction. So we'll give only for the Y direction. We'll uncheck all other directions and eccentricities. The importance factor is 1.2. So it's in a residential. R is 3. Then click OK. So we have the earthquake force in X and Y direction. Now we are going to consider the response spectrum method in X direction. Same conditions, click add new load. We'll modify the lateral load. Again, this is also X direction. 1.2. This is 3. Y direction. Add new load. We'll modify. This is also 3. 1.2. We have defined the load patterns. Okay. Now we will draw the member. So in previous video we saw how to draw the member. Now we are going to draw in a much easier way. We are just going to assign the material. By default we have the concrete column and beams here. We are just going to assign the dimensions of the frame section, frame members here. We'll go to select option, go for the object type. Here we'll select the beam. So the beams are selected. The primary beam and the secondary beam is also selected. So right now we are considering both the beams as same beam with the same dimensions. So we're not going to differentiate any primary and secondary beam. We'll go for, now we have to assign it. We have selected, now we have to assign. Go for assign, and there you will find the frame. Go for the section property. The section we have considered is concrete column section, concrete beam section. We will apply it, so the beams are assigned. It is displaying here that concrete column is also assigned, but the dimension we have to change and assign it again. We'll go again for select option. In select option, we'll go for the object type. Here we will select the columns alone. So columns alone will be selected. 64 frames are selected. We will close it. Now again we'll go for assign, frame, section property, column, apply, close. So we have assigned the beam and the column. Now we have to assign the slab member. Again we'll go for select option, select, object type, floors. Floor is also the slab member, horizontal member. So we'll go for the floors, select it. So the slabs are selected. Has a huge shell. It is selected. So we have 4 shells and 16 edges. The sides, 4 sides in one floor. So it is 16 edges. We have selected it and close. Now we have to assign it. We'll go for assign option. Here we'll go for the section, shell, slab section. We'll choose the slab one, apply, close. So the slab has been assigned here. After assigning, now we are going to apply the wall load on the beams. So the wall load is considered only for the 3 floors. On the top floor, we are not going to consider the wall load. So for 3 floors, we are going to assign the wall load. For that, we have to again go to select option, select, properties, frame section, concrete beam, select. So we have selected the beams. Close. Now, when we selected the concrete beam, by default, we have selected all the stories. If we select from this option, if we go for select, and here if we choose the options all story, irrespective of the single story, here it is mentioned or all story, this option tries to control all other work. So this option here, the one story or all story, is disabled when we consider the select option. So if you don't consider this option and you change any, if you do any changes here, it is applied only for the particular story in the pan or in the 3D view. If you go here, this one story or all story option will be disabled. So you can go here and select all the stories. Now after selecting, we have to deselect only the top floor because we are not giving the wall load on the top floor. So we'll go for the deselect option here. We'll go for the stories. Only at the top floor we are not going to give. So 4th story. Now here select deselect option. You just have this option. If you select now we will find the 3 stories being selected and the top floor is deselected. We'll go for assign option. Assign. This is the frame load. So we'll go down to the frame load and it is the distributed load. Here we will choose the wall load. So initially when we defined the load pattern, the same data would be provided here. So we'll choose the wall load, and the wall load is 9 kilonewton per meter when the wall thickness is 150 mm. So I have considered 150 mm thickness as the for the wall. So the subsequent load is 9 kN per meter. You will apply the wall load. Apply. So once you apply the wall load, you can cross check it. Click here to enable this window. Click down. You will find in the third story and the second and first stories, the wall load has been applied. You can find 9. That is the wall load we have been provided in the beam, on the beam. After assigning the wall load, we have to assign the live load. For that, we'll go for the option select, again select. So the live load is assigned on the slabs. We will select the slab section. Again slab 1, select. All the slabs are selected. So 4 shells are selected. We will close this. The live load is considered as 3 kN per meter square for the 3 floors. And on the top floor, we are going to have 1.5 kN per meter square. So now we are going to deselect the top floor and assign the live load for all the three floors. Only for the 3 floors has 3 kN. So we are going to deselect the top floor. Select, if you go for the option select, now here you go for deselect. Go to the stories, top story, deselect. Close. So the top story is deselected. The other stories are selected. We'll go for assign, shell loads, uniform. Here we are taking the live load. Load pattern is live load. The load is 3 kN per meter square. Click apply. Close. So you can see here 3 is mentioned here. For the 3 floors, it is 3 kN. We go down 6 meter 3 meter 3. Okay, so the live load is assigned as 3 kN for the 3 floors, and at the top floor we are going to assign the live load as 1.5 kN. We will go to the top floor. Just click here in one corner. Now the top floor is selected. The third floors are not selected because I have kept the bottom here as one story. So the top story is alone selected. I will go for assign option, shell load, uniform. The load is 1.5 kN per meter square. Again, it is the live load. We will apply it. Close. On the top floor, we'll have 1.5 is mentioned here. If we go down to the second and third floor, it is 3. So the live is also assigned. Now we will assign the floor finish. The floor finish for all the floors is 1 kN I have considered. So we'll go for the again same option, select, property, slab section, slab 1, select, close. So 4 slabs are selected. So 4 shell is shown here. So slab is selected. We'll go for assign, shell load, uniform. It is the floor finish. So EFF. This is going to be just 1 kN per meter square. Here we have to add to the existing loads. You should not take the option replace, then it will replace the 3 kN. So we have to take here the add to the existing load. So we are going to add to the live load. So here we have taken the floor finish 1 kN, add to the existing to all the floors, apply, close. Just in case if you have any doubt, you can cross check by clicking right click. If you just give a right click to the slab number, you can find the assigned members. So now the section property slab 1. So slab is assigned. These are the other things we will see in the I will go to that option also. Now if you go for here to the load, here the floor finish for the top floor is 1 kilonewton and the live load is 1.5. Close it, go down also, we'll just cross check it. Again here the live load is 3 and the floor finish is 1 kilonewton. So we have assigned the loads to the structure. So we have assigned the loads. Now we have to give the end length offsets. So here we have to again go to the select option, select properties, frame section. You have to select beam and column. Both the options we have to select. Click here, close. So the column and the beam are selected. After selecting, go to the option assign. Here go for the frame, and in the frame go for end length offset. Here consider the automatic connectivity between the column and the beam. So the rigid zone factor is 1. By default consider this value 1. The self-weight option is also auto. Then click apply, close. So once you applied it, just click the 3D option. You can find this connectivity. So the column and the beam are connected properly. So end length offset is assigned. Consider this in plan view right now. So now the 10th step is we have to assign the diaphragm. So we will go for select option. Again go for select. Here click select all. All the column and the beam and the slab will be selected. For the diaphragm, where the lateral load resisting is to be done by the beams and the slab, so we are going to uncheck, deselect the columns only. We'll go for select option. Here it is deselect, properties, frame section, column. The second option is column. First is beam, second is column. So we're going to select second, and this column only we are going to deselect it. Click deselect, close. So the columns are deselected and the beam and the slabs are selected. Now we'll go for the assign option. Here go to joint, and in joint you will find diaphragm. Click it, diaphragm D1. So click modify, you can find here. Again if you click modify, diaphragm is rigid. So we have given this rigid option while starting the model itself. In the rib dialog box we chose rigidity as rigid in diaphragm. So again the function is right here. We'll click OK, again OK, we'll apply it, close. So after applying it, you can find here that there is concentration here. Okay, so this is the diaphragm. The diaphragm has been applied to the slab members also. Now we are going to just define the load case. We'll go for here the define option. We'll go for the load case. Here the dead load is linear static, live load is also linear static. We have wall load, floor finish, it's all linear static. The equivalent static method, which is considered here for earthquake force X and Y, it is also a linear static. So by default these values are correct. So we are not going to change anything, we are not going to modify anything. But for the response spectrum we are going to modify. You have to click here, you have to select here, then you have to go for modify case. Here the load case type is response spectrum. We have this option response spectrum. We will select here, then just click add. This is acceleration in x direction, which is nothing but u1, and the function which we defined, it is RSM, response spectrum method. The scale factor here is 1 right now we are considering. Then these are by default, you will have these options. then click OK. Now for the Y direction also we have to modify. We will go here, response spectrum, add. Now this is in Y direction, so it is U2. The function is RSM. The scale factor is 1. Click OK. There is one more option that I went and changed here, but I can copy this load case, add a copy of this load case. I can copy this load case and edit also. So two options there. So I went, this option was already available, so I just modified it. So the load cases is also defined properly. The 12th step is to assign the support conditions. By default, we have assigned the support conditions from the first dialog box itself. So we'll go for the, I'll just cross check and show it to you. This will go for the bottom. So it is assigned. So when I clicked here, the X direction, Y direction and the reaction is all been restrained. It is a fixed condition. Click OK. I'll show it again here is also. Here if you go for the assign option and see, if you go to the assign option and see here, you'll find the fixed condition. For fixed condition, this one, all the direction restraint is available. So by default, when we started the model itself, it has been assigned. We'll close it. So we have even assigned the support conditions also. We'll go for the mass source. Now we have to go for the define, which is the 13th step. We have to go for define mass source, go for modify. Now uncheck these first two, element self mass and additional mass. Click the specified load pattern. Now here for dead load, the multiplier is 1, you will add it. And for the live load, it is going to be 25% for 3 kilonewton. So this is what our code book says, that for the live load, which has been distributed on the floors as 3 kilonewton, up to 3 kilonewton, then we have to consider the percentage of imposed load as 25, and if it is more than 3 kilonewton, then it is 50% we have to consider. So here for the live load we are considering 0.25 because the live load is 3 kilonewton. We will add it. Then for the wall load, it is going to be 1, add. For the floor finish is also 1, we'll add it. Again, we'll click OK. OK. So the 14th step, we have to run the model. So we'll go for the analyze option. Here, we'll check the model. And here you have to select all the options. Just click OK. When you check the model, we can find that any errors in our modeling, any connections is not provided properly. So we can check the model. Okay, so the model is clear, no warning is there. We'll go for the assign option. Run analysis, we can press F5 also, that is the shortcut key. Before that, we will save the model. I have saved the model. Analysis is being run. Okay, the model has been analyzed. So we'll go for, we'll see story response. So here, okay, before that, I'll tell you there's one more step to be followed, which is mentioned in our codebook. You have to go for display after the analysis, go for show tables. In that, just click the analysis result, uncheck these all things, just consider only the structure output, click OK. Now the equivalent static method, the base shear in the x direction is we'll consider as 908, and y direction it is 1089. So base at y is more, but the response spectrum value is very low, very less. So for that, our code also says that when in this condition you have to scale down the factors. So the design base year VB estimated is not less than the design base year VB bar, which is the response spectrum. Then we have to divide the value. So now we will take this value 908 divided by the response spectrum base year, which is 0.0965. We will divide it. We will get the value as 9409.3. Okay, we'll click done. Just using a manual calculator, you can divide the base year of the equivalent static and the response spectrum. Then again, we have to unlock the model. So after unlocking the model, so we'll go to the load case, define load case. Here we'll go again here, response spectrum, modify the value which we got 908 divided by 0.0965. So that is going to be 9409.326. We will click OK. Again here we will modify the scale factor and give the same value 940. Again we have to run the model. So this is the iteration process which is recommended by our code book. Just to match the equivalent static method and the response spectrum method. Now again we'll go for the show tables option. Same option, analysis result, structure output, we'll click OK. So you can find here that the equivalent static force and the response spectrum values are matching. 908 and here 907, it is matching. Okay, now this procedure is correct. Now we will go for the, we will check the other results option, which is in the step 15. So we'll go for the display option, story response plot. You click. Now this is the nodal part, x and y direction, which is same because it is a symmetrical building. So in x and y direction, displacements are mentioned. The maximum is 0.033 in the top story. Now we'll check the equivalent static in x direction. So the maximum displacement in x direction is 30.8 mm. So this is the maximum displacement in the x direction. Now we'll consider the y direction. So for y it is 36.99. So for x it is 30 and for y is 36. Now we'll go for the response spectrum x direction. For response spectrum, which is more accurate than the equivalent static method, here the response spectrum in x direction is 26 mm. Previously we saw for equivalent static in x direction it is 30 mm. Here it is 26 mm. And for y direction, again for y direction is also 26 mm. Okay. Now other results we can check. Go for the result display type. You can check the maximum story drift in the 4 load conditions: x direction, The values are mentioned here: y direction, maximum story drift. So just in case, here in y direction, the maximum story drift occurs in the second story. It is the maximum occurs in the second story. Okay, both are same. And for response spectrum, the maximum story is here, it is mentioned ry. Now we will check for the story shear equivalent static x direction. It is the story shear here. This value changes. Now you can see the story shear value. Corresponding point, you can see the story value. So at the top you will have the 344 kilonewton, and at the third floor you have 706 kilonewton. But in case if you want the readings and the values, you can have the summary report. If you go here, summary is only for this one. Detailed report, if you click, this is the detailed report. You will have the data also provided here. So this is the story shear value for all the load cases and the display type and case combo. You can have a detailed report also, and you can even generate the Excel format also, formatted and unformatted. You can have this graph. We'll choose here. We have to see the story shear. For story shear, x and y, and for response spectrum also you can view here. With these results you can check. So it's same, correct only. Then we'll go for the overturning moments. You can see the overturning moments also for each case combo. Story stiffness is also you can check. So these are story stiffness. Now I'd like to show you one more thing. We'll go for the, so now here we'll go for display. Just I clicked here, then you'll go for display. You will see the deformed shape. In that, just click mode, nodal, click apply. Close. So this is the first mode shape. If you click here, this is going to be the second mode shape. So the building sways. Now it twists. Again, these are the different mode shapes. So by default, the mode shapes are 12 different mode shapes. ETAB also does the animation of all the mode shapes. So this is for the mode 1, the building moves. You can even increase the speed and the so like this animation, you can see the stories mode shapes. And now we'll check for the earthquake load case for x direction. We'll apply. So this is the x direction equivalent static method. So this is the x direction equivalent. So if you see here, there's a small bar. You can increase the speed also. Okay, so these are some animations we have here. You can even record the animations. You have this option here. You can capture, record the animations, create video. So all these options are also available. So like this, for undeformed shape, you can have this option, equivalent static x and y, response spectrum, all those options you can check. Okay. And if you move near the frame. This is the displacement which has been happened, so you can find here. Now it is an equivalent static method. Here you can see the ux has 30 mm, so that is the displacement in x direction. Subsequent y direction, this is the value, and for z is the gravity up and down, so it is 0.195. So these are the results. So you can just move here and to the joints, you can find the results also. You can even generate the report also. Okay, so this is the analysis part for equivalent static and response spectrum.